All right, so for the second worksheet we had was dealing with trends. And whenever we're dealing with trends, there's a little mnemonic device to help us. The 4Ls: lower, lefter, larger, looser. So meaning the lower you go within a group or the further left you go within a period, the larger the elements become and the less tightly they hold on to their electrons. So atomic radius, this deals with our size. So in this case, lithium, carbon, and fluorine, they're all in the same period. And we want to go from smallest to largest. So lower, lefter, larger, looser. We're going to deal with lefter and larger. The further left you are, the larger you are. So in this case, we're going to look to the element that's furthest to the right, and that's fluorine. And then we end up with carbon and then lithium. That's our order in which these elements fall, largest to smallest. I'm sorry, smallest to largest. Here in letter B, it's basically we're looking at the same trend, but this time going down a group. Lithium, sodium, and potassium are all in the same group. And when we go down, when we do lower, we're getting larger. So lithium's the smallest, sodium's the next largest, and then lastly, potassium's the largest. If we look at this next group, I'm going to get my handy periodic table out. Of elements, we've got GEP and oxygen here. So lower, lefter, larger, looser. And if we look at those, they're neither in the same group or the same period, but the lower, lefter you go, the larger you are. So we're going to look for the one that's furthest to the top and to the right, and that's going to be oxygen. That's going to be the smallest. And then phosphorus, and then germanium. And then if we take a look at letter D, we have C, N, and aluminum. The further left we go in the periodic table and the closer to the top we are, we're smaller. So nitrogen is going to be the smallest, followed by carbon. And lastly, aluminum's down one row further below. It's going to mean it has an extra shell. It's going to be a little bit larger. It's a little further to the left. And then for the last one, for atomic radius, we have aluminum, chlorine, and gallium. So let's find those on the periodic table. Aluminum and chlorine are in the same period, and between the two of them, chlorine is the smallest. And then aluminum and gallium are in the same group. Between those, aluminum's a little further up, so it has less shells. Gallium's a little bit below, so it has more shells, so it's going to be larger. Ionization energy deals with the amount of energy it takes to remove an electron, so we're going to be dealing with our looser part. The higher the ionization energy, the more tightly the electrons are being held. So we want to range these from lowest to highest in ionization energy. The elements with the highest ionization energy are going to be the upper right. The ones with the lowest ionization energy are going to be the lower left. So magnesium, silicon, and sulfur, they're all in the same period. Magnesium's furthest left, so it's going to hold on its electrons to the loosest, and then silicon, and then sulfur. If we look to magnesium, calcium, and barium, the lower we go, the looser they become, and magnesium, calcium, and barium are all in group 2. So magnesium, calcium, and barium, that's our order. Well, I'm sorry. It's the opposite. Barium, calcium, and magnesium for the same reasons I said before. So magnesium holds on to its electrons the tightest between these three because it's the smallest. Its electrons are in closest to the nucleus. Barium's all the way towards the bottom. Lots of shells, not a whole lot of attraction for electrons. Take a look at letter C. We've got fluorine, chlorine, and bromine. They're all halogens. The closer to the upper right you get, the highest the ionization energy becomes. So we're going to start with bromine. It's the biggest of the three. Therefore, the furthest away from, its electrons are furthest away from the nucleus, followed by chlorine, and then lastly, fluorine, the most electronegative or highest ionization energy on the periodic table. And then let's take a look at barium, copper, and neon. Or I'm sorry, let's see, neptunium. No, it's any neodymium. Having a blank, I'm sorry. Barium, copper, and neon. Barium, lower left, copper kind of in the middle, neon upper right. So from least to highest is going to be in that same order: barium, copper, and neon.